So yeah, we need all these things for this for making this Saurmandalam. Okay, I think let's begin with it, or you are collecting the stuff with you. Okay, let's take 5 minutes, 3 minutes. So people will take these things with them. Some paper, some pencil colors, button sales. If you have copper adhesive tape, then it's okay. Otherwise, you can use the that flexible wire, single strand. That is also okay if you don't have this copper adhesive tape. Yeah. So objective of this workshop is like not to understand the only Saur Mandala, but to understand the simple concept, like how we can teach our students, like to connect with their syllabus or the chapters. So I will show you. In meantime, I just want to show you one thing. Okay, so see this syllabus, like I am making this activity plan for the Cambridge University for Singed Education High School. So they have chapter for 9th grade, like making measurements. So this is the first chapter for them. So I have suggested activity like make a mold on 3D printer or the machine with the different size, so they can understand about the length, volume, and the time consuming. Then describe the motion. So they have like learning about the distance, time, speed, and acceleration. So I have suggested them activity like make a time lapse machine, so that student will understand how exactly the motion, distance, time, and speed can relate with each other. So this is, you can see some activity I have actually planned for them. The 1 minute left, then we can start our activity. Okay. So yes, let's start with the activity. So what you are actually going to start with, if you have this white color paper or anything, any color paper, just start making the solar system. You know about the solar system, right? There are like, so just draw this kind of thing, like Sun, Mercury, and all these planets name. Simple drawing. This thing you need to do. You can do it by freehand. You can use your compose or something to make arc. Okay, great. Yeah. Okay. So can we go for the next step? If yes, then thumbs up. Okay, cool. So on next step, you have to select your favorite star. Anyone. Or then you need to just take LED in your hand, and I'm just putting it to the earth. So I'm placing this LED to the earth, like just press it to for the marking purpose. We need marking inside. And the battery side will directly go to the sun. So in corner we have actually designed the sun. So what we are doing exactly? Are you able to see this orange thing? Or I need to. So this is a simple series circuit. Like we are using like I have drawn the LED exactly where I have marking on the earth. So this is earth outside. So I have just marked inside like LED, and then the last side of sun there is a battery side like. So this how this is look from the inside. It's a simple series circuit. And now I'm just taking this the copper adhesive tape with me. Yes. So if you have copper adhesive tape with you, then you can use that. Otherwise, just 1 minute. Otherwise, you can use this kind of wire, like this single strand wire, which is where we are actually using for the electronics things. The single strand flexible wire. If you don't have copper tape, you can use this wire.
Sorry, there's a message in the chat. It says if you could show that again, I think referring to the simple circuit on the paper that you were showing earlier.
Yeah, sure. So this LED is placed where my earth actually is drawn. And the sun side, like where I have drawn the sun, so there will be a battery. So I will just paste the copper tip so it will be a visible, more visible. So this copper adhesive tape is very useful for like when you're working with like K to 12 grade students. Like for the basic level, we need to start using with the copper adhesive tape. So they will feel like more interesting, and we don't have to take care about the electric shock or burn or anything that causes like happen from the soldering gun. So it's simple, like you can remove. Many people may be aware about this copper adhesive tape. Yeah. So I'm just sticking on my LED side, like so it's something look like this. So upside, you can see the LED legs came out from the this earth. So this is my earth. So I have insert the LED in the earth. And when there is a two legs coming from this side, I have pasted it on this copper tip. Just insert the LED where you want, somewhere like, see, you can see there is a sun, Jupiter and everything. So just simply insert the LED, any one of it. Okay. And after inserting, there will be a two legs come from the outside. So you need to like press it on the paper. Yes, good. Alexandra, right? Yes, so this is similar like that. If you, so we need to keep one connection loose. Yeah. Oh, great. It's blinking. Cool. Matthew, sir. Yeah, good. So here mine also start blinking. See. So yeah. So this is the last objective. Like if you press on the sun, then it can like there is a like luminous star and like there is a, sorry, 1 minute. Yes. So learning outcome will be like there is a, some stars like the luminous by their own light and some is illuminated. So this is the concept behind this model. So if you press on the sun, it will blink. If you remove your hand, it will stop. So this is like very basic because we have only 45 minutes. But in case you can like it connect all these stars with different LED and you can actually vary it with the different light. So you just need to understand about the circuit inside you are making. So all game is about here. So like third grade students made this kind of circuit as well, like this greeting card. So they have made some lamp and they have put the LED here and the circuit is inside. So if you press here, so LED will blink here. So right now actually LED got outside because of some, like I keep it at the mess actually. So yeah, so you can make any kind of greeting with your kids, like any occasion, like you can host the occasional workshops and you can teach them like how to make greeting card. Like this is for like preschool or some like students till 10, 8 or 10th age group. So they will enjoy this activity and it will be not hazardous for them. So this is a simple copper circuit. So what is the learning outcomes we actually got from this activity? Like making a paper card with different shapes. So you can use any shape. So right now we are actually using the simple rectangle things. So you can use different shape. You can make circle or you can make heart shape or you can make hexagon, pentagon, anything. So this will help them students to understand the mathematical concept, like how the shapes and what is the calculation, because we need to calculate the inner side as well. So right now we are actually we have made randomly, but here we need to calculate and figure out the things, because this case we are using the single LED. But if you are using more than 2 LEDs, you need to calculate all the space and the flow of current, because madam, what happen if you are not using this copper tape like in straight direction, or it is some uh, crumpy or something, so it won't get like flow the current like nicely, so it may causes the loose connectivity or this kind of thing. Second thing is about like solar system and its planet name, so it's all about the science and physics involved here. Then it's about the like simple series circuit, again it's science. Then basic electronics, like what is the LED, what is the battery, and what is the wire, and what is the current, how the current flows. So positive like anode, cathode, it's all about the technology. And student will also understand about the difference between luminous star and illuminated star, because they are in solar system, there are many star like they are luminous, they glow by their own light, and some are dependent upon the sun. So this will be understand to them. And also if you are making for the occasion for the family, so it will add the value and the moral for the family or for the community, anything. So that thing is one more. And also the drawing thing is like student will understand about their art activity, so they get opportunity to make designs, different art. So some students know about more about the like some birds and this kind of drawing, so they can draw like that way. So yeah, so I'm just trying to give the simple like example of how to integrate STEM into the simple projects. But you can also add with the like after this simple series circuit, you can make some game for the students as well, like by using you can just provide them a kit of the cardboard paper, some copper tape, some LED, and they can actually design different circuit with the different shapes and sizes. And yes, so this is what my target is, the Fab 8 2023. So it's about like connect, innovate, inspire. So this is what I'm doing. I'm actually going to the schools. I'm living in the coastal side of like Maharashtra, India. So here, like many people not aware about the technological thing or technical thing. They spend like 500 or 1,000 rupees, Indian rupees, for the mobile recharge, for the internet purpose, but they don't wish to pay for the education. So this is the mentality. So many times what happened, they are not able to reach to our maker space. So we actually going there and we are actually teaching them in a classroom, and then they got like connect, then innovate, and they get inspired, and they start to come to our lab and they start making things. So this is the all concept about the simple solar mandal, or the how to integrate school curriculum into projects in a fab lab. And as I have mentioned about the things, so this is just something about like ninth grade, but I have for school educational as well. I will share one more document with you. Yes, so this is the Indian government syllabus for the 5th grade students. So in that they have a chapter called.
Sorry, we can't see the syllabus that you're sharing. We're just seeing the overview still.
Right now? Okay. Now?
No, we're still
Yeah.
seeing the overview.
Okay, I will share my screen. Now?
Yes, now we're seeing the syllabus.
Okay, so this is the Indian government syllabus. So actually I am planning this curriculum for them. So what I'm doing, I'm going to the actual website of the educational department NCERT, and then I'm downloading the syllabus, and then I'm trying to like plan the activity for them. It's not all about the electronics, but some on the livelihood training as well. So there is a chapter called nutrition plants. So in classroom, you can't teach them the how to like nutrition the plants. So I have planned them activity like in agriculture, mushroom cultivation, azolla bed, spirulina bed, making in the school. So what student will do, they will go into the like in classroom or in class session, they will make small bed and they will cultivate the mushroom, azolla bed and the spirulina bed in the, because in small area they grow fastly. So this is the plan for them. Then test the nutrition value after making a final product. Like azolla bed take 15 days to grow. So within 15 days, oh nice. There's another circuit I can see in the screen. Good. So this is some activity I have planned for them, like for the physical and chemical changes. There is a soil testing thing, then adaptation, like weather, climate, and adaptation of animals to the climate. So there is the study of biodiversity and this thing. So you can actually you can read it and you can get idea what I'm trying to tell you. So my main focus is on the hands-on skill, not depend upon the classroom teaching, not depend upon the internet surfing thing, or not depend upon the teacher. When you are doing something by hand, it will be last long in your mind. When you grow up, this still you remember the things. So this is the basic motive about these workshops and these things what I'm showing. Like, so there is another syllabus for the 8th grade, and also I'm helping them to make a tool list for each and every project. So yes, thank you. It's very quick workshops and I'm trying to like tell you the maximum I can. If you have any doubt, please go ahead, and thank you very much. And you guys are awesome. You do like very rapidly actually. Thank you very much.
Yes, so we do have about 13 minutes left. So if anybody has questions or if you would like Pradnya to elaborate on anything that she's talked about today, this is the time for that.
So even I would like to know about the participants, what they are doing, and it will be like good exchange and enhance the knowledge.
Matthew is talking, but his sound is off.
Oh, I wasn't talking, but yes, I can. So thank you very much, Pranya. I wrote that in the discussion board. I had to run in the office to find something to make the wires. So I first I found this graphite pencil that I use sometime with Mekis to do some, but the conductivity of the graphite wasn't high enough, so the circuit could be used. So I had to think quick and to look around what I had, and I had some soldering wire, and so I give it a try. I was looking for real wires or other suggestion you had, but I didn't have it, so I use it and it worked perfectly. So what I'm trying to say is, when you have a workshop like that, to have a diversity of materials so the students can use the experiment, this will increase l'apprentissage, the learning of the students. They will try like me something that won't work, and the student will have to think for something else. So don't, I encourage you to, not talking to you specifically, but don't do little perfect kits with everything in a little bag with that that will work. Throw things that won't work, and to put in a little bit of trial and error approach. So thank you, Pranya. Your activity just make it remind me a lot more about that, the importance of making some
Yeah.
mistakes.
Thank you. Thank you so much. Yeah, it's all about exploring. Like we need to give the free hand to students, like go and explore and like try to make things do. This is the really best part. And another thing is like keep it simple. Like whatever the theory, I believe always like keep it simple. Don't get too much critical, or like don't go for like advanced things or something that scare you and then you can stop in between. So keep it simple and explore. Yeah, this is the best thing.
Alexandra, I think you raised your hand.
So I agree totally with Matthew, and one precision that electronics like this usually fail or don't work because the connections don't be very quiet. So there are many mistakes in between, and so this is the kind of works that they have to try and fix and debug or whatever. But sometimes I understand to have a kit or something that I know that will work can more easily reach a goal for understanding something simple thing. The other way is by tinkering and give stuff to discover and to have know and
Have a goal.
a goal or an answer or something like that. I believe both have can happen, and we can use both approach. One with, because sometimes when people make tinkering with the goal, and I see this many times. So in tinkering, I believe is no goal, is no right or wrong, and give stuff many and to and encourage to find and discover and try. The other way is not a other way, is another approach that I think is also have a value, that if you like in instruction, like step by step, and you will understand something with step by step. For example, what is the anode and the cathode, and you have listed the things, the positive or negative. So I believe both have a purpose, and you can use both. Sometimes I use the tinkering for exploring, and then one activity step by step to consolidate or to give some information that could be more accurate or detailed.
Yeah. Great. Thank you. Anything anyone want to add? Or
Yes, thank you, Alexandra, although I think that's not your actual name, the person who was talking. Thank you so much for that. And I really do agree with you 100%. A lot of times people see tinkering like as a failure if you don't reach the goal, right? But that's not correct, and we have learned that, right, as Matthew spoke earlier, that he couldn't, that it wasn't working at first, so then he had to make it work, right? That is, for someone else that might have been a failure, but of course it was not. What I would like to say, Pradnya, is your work is commendable. I think a lot of times we focus on buying materials, right? for our worker spaces. We need 3D printers, and we need 5, 6, 7 laser cutters, and all of these things that cost so much money, and they are beneficial, right, in worker spaces and in classrooms. But if you just take it to the basics, the children still learn just as well, right? So, and you stated this in while you were presenting as well, where the parents or the children might not know too well about the classes and about the things. So you go to them, you teach them the very simple things with very few technologies, and then they become interested. You ignite that spark so that then they do go to you, and then they can use the tools and materials in your worker space. So I think it's incredible the work that you're doing. And I can tell just from the syllabus that it's a lot of work and it's very hard, but it just shows the dedication and the passion that you have for teaching. So it's, I applaud you for all your hard work, and thank you so much for presenting. I didn't actually get to do the activity because I don't have, I'm not at my makerspace, so I don't have the tools, but it was just so fun seeing everybody get it to actually work, right? Because at first I didn't know what was going on, but I'm just so happy and so excited, and thank you so much for presenting.
Thank you so much, everyone.
Yeah,
it was really nice to meet you, all of you, and yes, to interact with you and learn from you as well. So thank you for hosting us.
yes.
Yeah.
Nice to meet you.